All right, we're going to take a look at this problem that has a lot in common with the bicycle wheel problem we did a couple of weeks ago. So we've got Mark Twain sitting on the deck of a steamboat watching a paddle wheel spin. You can see that there. As it spins, a point on the blade moves, so its distance, d, is a sinusoidal function of time. It's distance d above the water. So basically, we want a function that we can put in a time and get back a height above the water. All right, so we have some specific information here. It says after 4 seconds, the point reaches its maximum height of 16 feet above the water. We are also told that the diameter of the wheel is 18 feet, and the wheel completes a revolution every 10 seconds. Okay, so this problem is going to ask me to make a graph and figure out lowest point. And the key here for me, though, is writing the sinusoidal function equation. Okay, and just like normal, if we can find an amplitude, phase shift, midline, and period, this is going to be a piece of cake. My suggestion is, because we're already pretty good at writing the equations by looking at graphs, try to draw the graph first. Okay, if you can plot a couple of points, you're going to be able to figure out all those key features pretty easily. All right, so let's go ahead and take a look at this here. Number one, it says after 4 seconds, the point on the wheel reaches its maximum height of 16 feet above the water. So I've got a little graph over here. So after 4 minutes have gone by, this thing is going to reach a height of 16 feet above the water. Okay, so we're going to have the point 416 as one of the points on our graph. Okay, so that's a point right there that we're starting off at. All right. Notice that it completes a revolution every 10 seconds. Okay, so that means 10 seconds later, this wheel is going to be back to the same place. Okay, it's going to be back to, and be careful, 10 seconds later would be 14 seconds in. So it should also contain the point 14, 16. Okay, and now if you think about this, the wheel has a diameter of 18 feet. So if it reaches a height of 16 feet out of the water, that means it has to dip 2 feet below the water. So this sinusoidal function should reach its low point, and it should be 2 feet below the water, exactly at the halfway point between 4 and 14, which, by the way, would be at a coordinate of 9, would be where that would take place. And so now if you draw a picture of your graph, we've got this sinusoidal function that's basically doing this kind of thing. That's not my best drawing ever. Let's try this with my finger. We've got this sinusoidal function that's going through the points like this. All right, and we should be able to take that and put all the pieces together. So the amplitude here, this graph is going as low as -2. Okay, so notice the diameter here is going from -2 up to 16. The amplitude is going to be half of that distance between -2 and 16. Okay, and that's going to make the amplitude 9. Okay, the midline is going to be exactly halfway between 16 and -2. So you can probably average 16 and -2, add them together, and divide by 2. And you should end up with your midline being at 7. Okay, so that's where my midline is going to take place. It's going to cut through here at 7. Okay, notice you go up 9 to 16 and you go down 9 to -2. And so in general, that's what my graph is going to end up looking like. Okay, so the midline is going to be at y equals 7. I'll go ahead and put that in. Okay, a couple other things here real quick. I'm going to make the period here using the 2 maximum points. We're going from a maximum point of 4 to a maximum point of 14. That means the period is 10, not 10 pi, 10. Okay, and we're going to use that. Now the phase shift, you can decide whether or not you want to use a sine or a cosine function. We need to be careful. You can't actually tell if it's crossing the midline at exactly 0. I'm guessing that it's actually not. I think it would make more sense to use the cosine function and basically use that point right there. So we'll talk about that in the next video in just a minute.